Okay, so what we're going to have a look at today is basically all of the exponent laws that we've done so far, as well as having a look at zero exponents. So what I've done here is at the bottom, I've put the 4 laws that we know or we should know. And then I've put the sort of, we don't call it a law, we call it a definition of exponents because it comes from one of our laws, and you'll see this in a second. Just so that it's all grouped together, you know exactly what rules we have done, you know exactly what rules you need to know or laws you need to know. So hopefully it's something that you have ready, waiting when you are studying. So I'm just going to leave it up there for a second in case anyone does want to just take a screenshot of all of these rules all together. Otherwise, we're going to have a look at some examples and some questions now in a second. Oh. Alrighty, so let's have a look. The first thing we wanted to chat about is the zero exponent definition. Now, like I said, it's not a law, it's a definition because it actually comes from one of our laws, and it comes from the divisional. But let's see what actually happens when we have a zero exponent. So we know from our law of division that when I divide the same bases and their exponents, what we actually end up doing is we end up subtracting the exponents. So if, for example, I had 3 to the power 3 divided by 3 to the power 2, my second law of exponents tells me that I should subtract those exponents, leaving me with then 3 to the power 1 or just 3. And this is now where we get to our zero exponent law. So if we have a situation of, say, for example, 3 to the power 3 divided by 3 to the power 3, according to our division law, what we need to do is we need to subtract the exponents, so 3 minus 3, and that gives me 3 to the power 0. But what we need to know is what does that actually mean? Now, if we take a little tangent here, and we think about what happens when we divide a number by itself. So we can pick any number. 3 divided by 3. 5 divided by 5. Negative, I don't know, 11 divided by a negative 11. Whenever we are dividing a value by itself, we are always getting 1. Okay, it goes into itself once. And this is essentially what we're doing over here when we say 3 to the power 3 divided by 3 to the power 3. I'm dividing the value by itself. And so just because of basic division and what we know happens when we divide something by itself, we get an answer of 1. And this leads us to our exponent law that tells us that when we raise something to an exponent of 0, my answer is going to be 1. So anytime we have something to the power of 0, our answer or the value of that is 1. And that is because essentially what we're doing is we're dividing the value by itself. We're saying 3 divided by 3 or x divided by x or whatever it is, but we're dividing the value by itself. And we know from division that ends up being 1. Okay, so that is sort of our zero definition. And we're going to have a practice of that and then the other laws that we've learned so far throughout this lesson. So if you're feeling a bit unsure, we are going to practice. So don't stress. But let's have a look. I'll stay here just quickly in case anyone wants to take a screenshot of this explanation. Otherwise, I'm going to move to the examples. Alrighty, guys. So let's have a look at some examples here. Let's start with question A. We've been asked to simplify the following. Now, there's a couple different ways you can approach this, and with exponents, that is what's quite nice about them, is that you can do them in many different ways. So we know from law 3 or law 4, doesn't really matter which one, when we have a bracket raised to an exponent, we know that what we do is we distribute the exponent into the bracket, and hence we multiply. So what we could do here is we could say x to the power of 2 times 0. But we know that anything times 0 is 0. So actually all we have is x to the power of 0. And as we've just discussed, whenever we have something to the power of 0, our value is always 1. Because what this is saying is x divided by x, and anything divided by itself is 1. And so to simplify this fully, we would say that our answer here is 1. Now, another way that you could look at it if you wanted to is that you've got the entire base. Remember, the base is below the exponent to a power of 0. So if your whole base is to the power 0, then it's just equal to 1. We don't really have to do much more than that. But if it helps you to think about the distribution, remember that you distribute the 0 into your bracket, and so what you end up with is 1. All right, guys, can I just get a thumbs up, thumbs down in the chat if this is making sense, if we're following what's going on, just so that I can see where we're at. So you can just put a thumbs up or a thumbs down based on how you're feeling. Chi-Chi, I see your hand.
Ma'am, can you hear me?
Yes.
I just want to make sure that, like, when we have example 1 in our test, and like we just put the 0 into the bracket and times it, and we get x to the power of 0, we just replace the x with 1 only.
Yeah, so the whole thing becomes 1.
Okay.
Yeah, exactly. Alrighty. Ukanyo, question? No? Okay. Alrighty. So guys, it looks like there's quite a few thumbs up. Very importantly, and this is in response to Atini's question, we don't leave it as x. We have to write 1 because it's not x. Whenever we have something to the power of 0, that value is 1. And so we need to write 1 as our answer. We can't leave it as x to the power 0 because that can be simplified further. It's not x because essentially what you're doing is saying x divided by x, and that is 1. So we need to write down 1 to show that we understand that that whole situation simplifies to 1. Right, I'm going to leave that there for a second in case you want to take a screenshot, and then I'm going to scroll across to B. Alrighty. Okay, so let's have a look at B. Now, once again, you can think of this in a couple different ways, but let's apply the laws that we know. So right now we've got a bracket raised to an exponent, and that means we need to distribute. Now, guys, remember, if you don't see an exponent attached to a number, there is actually an exponent of 1 there. So this 2 does have an exponent of 1. We just don't write it there. And so what we want to do now is we want to distribute the 0 to all of the exponents inside my bracket. So I have a situation of 2 to the power 1 times 0, x to the power 3 times 0, and y to the power 2 times 0. Now again, we know whenever we multiply something by 0, we get 0. So actually what I have is 2 to the power 0, x to the power 0, y to the power 0. And we know from our definition that anything to the power of 0 is 1. So that therefore means that this 2 to the power of 0 is 1, or has a value of 1. This x to the power of 0 has a value of 1. And this y to the power of 0 has a value of 1. Now, if you are just saying 1 times 1 times 1, all you have left is positive 1. And so because all of those bases are to the power of 0, it means that all of them have a value of 1. And so our answer at the end is just 1. Right, so this was a slightly more complex example. Again, can I just get some thumbs up, thumbs down in the chat so that I can see how we're feeling about it? Nice, guys. Well done. Nice. You're on it tonight. Well done. Okay, again, take your screenshots. And I'm going to get you to try one by yourselves. Okay, Chichi, the second one, I'm assuming you mean B. So we distribute the 0 into the bracket. So we make sure that we are multiplying this exponent outside with all of the exponents inside my bracket. And that means that all of these exponents are essentially being multiplied by 0. Whenever I multiply something by 0, I get 0 as my answer. And because anything to the power of 0 is 1, I know that the value of each of these things raised to the power of 0, so the value of each of these bases to the power of 0 is actually just 1. And so when we multiply those 3 ones together, we end up with positive 1. So because everything was to the power of 0, it means that everything had a value of 1. And so my answer is just 1. Right, I hope that makes sense. Remember, guys, keep asking, keep making sure that you're happy with what's going on. Alrighty, so I want you to try question C for me. Give it a go. You're welcome to put your answers in the chat. Remember your laws. So remember that distributive law of exponents. And remember what happens when you have something to the power of 0. Again, remember, you're welcome to put your answers in the chat. We like to see how you're doing as you go along. And if anyone's feeling brave, you're also welcome to raise your hand to let us know what you did. Okay, I'm seeing some answers slowly trickling in. Okay, Eddie, what do you think?
Ma'am, so first of all, you'd have to say 3 to the power 1 times 3, and that would give you 27. And then C would be to the power of 6, because it's 2 times 3. Okay. And then D is 0 times 3, so I think that would not be there.
Okay, and why would it not be there?
Because it's to the power of 0.
And that means it has a value of?
1.
1, exactly. Okay, so guys, like Eddie said, that D, because it's to the power of 0, anything to the power of 0 is 1. So that D actually has a value of 1. Now, 1 times 27c to the power 6 doesn't change anything. It still is 27c to the power 6. Now, just so that we're all clear, 27 came from this 3 to the power 1 times 3, because that's 3 cubed, and 3 cubed is 27. And the c to the power 6 came from the c to the power 2 times 3, and we know that 2 times 3 is 6. So just remember to distribute and then check where your 0 exponents are. Because the things with 0 exponents essentially fall away because they're 1 and they don't actually affect anything. And so here our final answer is just 27c to the power 6. All right, very nice, guys. You're doing really well. If you tell me where you're not understanding, I can try and help a little bit. I'll explain it one more time just in case. So what we do is we use the distributive law of exponents to multiply our outside exponent to all of the exponents inside my bracket. And what that means is that I then have exponents of 1 times 3. So remember, there's a 1 attached to the 3. 2 times 3 for the C, and 0 times 3 for the D. Now, anything to the power of 0 is 1. So that whole value for D to the power 0 is actually just 1. And then we need to go and apply the rest. So the 27 is coming from me saying, sorry, I'm trying to get a pen, is coming from me saying 3 to the power 1 times 3, which is 3 to the power 3. And you can do that on a calculator, but otherwise it's 3 times 3 times 3. Now 3 times 3 is 9, and 9 times 3 is 27. So that's where I'm getting the 27 from. And then the C to the power 6, I'm getting from my distribution again. So I distributed 3 to the 2. So I multiplied the exponent of 3 with the exponent of 2. And that gave me an exponent of 6. And so I've got C to the power 6. Okay, now guys, what you can sort of visualize this as if you want. I wouldn't do this all the time just because it gets a bit time consuming. But remember, this exponent 3 outside the bracket is saying that I'm multiplying the bracket 3 times. So I'm saying 3c squared d to the power 0 times 3c squared times d to the power 0 times 3c squared d to the power 0. And that's just normal multiplication then. Those brackets just represent normal multiplication step where I can now just go and multiply my terms together. And so if we start with the numbers, because remember SNV, oh no, put some weird bullet points in, SNV, everything's positive here, so I don't need to stress about the signs. But now when I get to the numbers, I've got 3 times 3 times 3, which is 27. And then I've got to multiply my variables. So if I go to all the C's, C squared times C squared times C squared, I add all of those exponents. So 2 plus 2 plus 2, which gives me C to the power 6. And then when it comes to the D, or the D to the power 0 rather, we know that anything to the power of 0 is 1. And so they actually all just fall away because they all have a value of 1. And so our answer is 27c to the power 6. Now, I wouldn't recommend you expanding your brackets like this, especially if your exponent is big. So if it was like to the power of 21, you don't want to have to go and write the bracket out 21 times. But it is just useful for you to see why we then just multiply the exponents. Alrighty, so I'm going to wait there for like 20 seconds in case my words. Oh, in case you want to take a screenshot, and then we'll move on to the next one. Righto, hoping we all have screenshots. Oops. Right, so let's have a look at D. I'm going to let you try this by yourself, but what I do want to say is that remember, whenever you have a negative in front of a bracket, what you actually have there is a ghost 1 in front of the bracket. So technically what we have here is negative 1 times bracket 3x to the power 0. So just bear that in mind when having a look at the sum. But I want you to give this a try by yourself. See what you get. If you want to raise your hand, you're more than welcome to. If you want to put your answer in the chat, you're obviously more than welcome to. But let's see what we get. Let's see how we do. Ooh. Excuse me, guys. Ooh. And remember, if there's no exponent written there, there is actually an exponent of 1. We just don't have to write it down. Okay, really see some hands. Esther, do you want to help me out?
Yes, ma'am. So any non-zero expression raised to the power of 0 equals 1.
Perfect.
So the answer is -1.
Excellent. Well done. So guys, what Esther just said there is any non-zero value raised to a 0 is 1. Now that is exactly what this is. 3x is not 0. It's raised to the power of 0. So this actually has a value of 1. And then we still have to multiply it with a -1. And we know that -1 times +1 is a -1. And so exactly, our answer here is -1. If you don't feel comfortable just going straight to the 1 from the 3x to the power of 0, remember, you can always distribute. So what we can do is we can distribute this power of 0 to the exponent of x and to the exponent of 3, which means we would have -1 times 3 to the power 0, x to the power 0. And then we know that everything to the power of 0 is 1. And so what you actually have is -1 times 1 times 1, which still gives you -1. So you can do it in different ways. You need to decide what makes sense for you. Tandor?
Hello, ma'am.
Hi.
Ma'am, I don't understand how you got to -1.
Okay, so I got to -1 because if we go on the left here, a negative times a positive is a negative, and 1
Yes, ma'am.
times 1 is 1. So it needs to be -1.
Okay, I'm actually saying like from the very beginning where
Oh, that,
yes,
okay.
yes, ma'am.
Right, so that -1, all I was doing there is just reminding you that whatever the value of this 3x to the power of 0 is, still needs to be multiplied by a -1. So it actually has, so even though there's no -1 or there's no 1 written in front of the bracket, there is actually a ghost 1 there in front of the bracket that we just don't write. Remember, it's the same as if you have a variable. If we just have x, there is actually a 1 in front of the x, we just don't write it in. And the same goes for a bracket. If there's just a sign and then the bracket, there is actually a 1 there, we just don't write it in.
Okay.
So then from there, this whole bracket, 3x to the power of 0 has a value of 1. And so then we're saying 1 times -1. If you don't want to think of it like that, that's fine. You could also write it as, let's go this way, negative, this whole bracket, 3x to the power of 0 has a value of 1. And so a negative times the 1, or the negative in front of the 1, gives me an answer of -1. Does that make a bit more sense?
Okay, ma'am. Thank you.
Okay. Nice, great, nice. Righto, so I'm hoping you've taken your screenshots. We're going to have a little bit of a brain break now because I feel like I also need to have a bit of a stretch. Get my blood flowing. Alrighty. Panic, panic, panic. Right. Our brain break today. The picture below shows identical right-angled triangles. Let's just grab a highlighter here. Identical right-angled triangles. Triangles next to each other or next to one another are connected along their edges. So they all fit perfectly together. What is the angle at the tips that are marked with the dot? So basically, they want to know what size are, I'm trying to pick all of these angles at the top of the triangles. That is my question to you. If you need a hint, you can let me know. So on the chat, just say hint, and I'll see how many hints I get. And then I will maybe give a hint. Boaz, do you have a question or do you have an answer maybe? Boaz, you there? Okay. All right, guys, my hint to you is this. Firstly, Atini's put there on the chat, I told you that these are all right angles. So think about the fact that they all have a 90-degree angle over here. I'm not going to draw them all in. That's my first hint. Second hint is if all of the sides fit perfectly together, what do you have in the middle? You've got all of these angles forming a circle. So you've got all of these angles around a point. So that's my hint. Boaz, do you want to try again? No.
Ma'am,
Yes, there we go.
it's the revolution, ma'am.
Okay, and a revolution is how many degrees?
360 degrees.
Perfect.
Yeah.
So, yeah, you're right. So this green circle, the whole thing is 360 degrees. Now, how many angles do I have making up the circle? I've got 1, 2, 3, 4, 5, 6, 7, 8.
8.
All of, maybe I should count. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 9. It would help if I could count properly. Now, if all of these triangles are exactly the same, could I work out what one of these little angles are? What do we think, guys? You can pop it in the chat. If you know that all 9 of them together are 360, can you work out what one of them is? Eddie, do you want to help us out?
Ma'am, I'm not sure if I'm right, but I said it would be 45, because if you add it, you get to 360.
Okay, so very close. I made the same mistake earlier just because I couldn't count how many angles. We would take 360 and we would divide it by the 9 angles. Do you agree? Okay, sorry. Right, so we would take 360 and we would divide it by the 9 angles. When you divide 360 by 9, you get 40, as my wonderful people are saying on the chat. So all of these angles around the center are 40 degrees. Again, I'm not writing them all in. We know that the red angle that I've drawn in is 90 degrees. And so we can use the fact that we know that angles in a triangle must add up to 180 to get what this third angle is. And so that means that the angle at the tip of the triangle is 50 degrees. Okay, because if we use our angles in the triangle, which is 180, we can go and get that third missing angle. Very nicely done, guys. This was from I think this was from a Maths Olympiad. So like the point was to be a bit of a challenge, but you guys handled it really nicely. Well done. Don't know if anyone wants to take a screenshot, but I'm just gonna wait there just in case. Right, I'm hoping all of those 40 degrees are in response to the 360 situation, not the answer, because remember the answer is 50. If we've got an angle of 90 and we've got an angle of 40, the missing angle is 50. And Blessings put a beautiful working out there on the chat because of sum of angles in a triangle. All right, let us carry on practicing some exponents. Right, so you've got two questions here, E and F. I want you guys to give those a try for me. You can put your answers in the chat. If you are putting answers in the chat, please just number them E and F so we know which is which when we see your answers coming through. But remember what a zero exponent means. Remember your distributive law. And just go step by step. Do not rush this. Go slowly, because often with exponents, we make silly mistakes. So go slowly, work it through properly, avoid those silly mistakes so that you can get the full marks for this question, or these sorts of questions rather. Okay, so remember those zero exponents. What does it mean? Remember all of your laws of exponents, especially the distributive law. That becomes quite useful, I suppose, in exponents, for lack of a better description. And guys, just remember, if you join late because of load shedding or connectivity issues, don't stress. Everything's recorded. You can get the recordings online tomorrow. Seeing some answers coming through, liking what I'm seeing so far. Remember your variables. Okay, Amakle, do you want to help me or do you have a question?
So ma'am, are we doing E?
E and F, yeah.
Okay. For E, I said 2 to the power of 1 times 0.
Okay,
And then I said x to the power of 1 times 0
good.
times negative 3 to the power of 1 times 2.
Mm-hmm.
And x to the power of 1 times 2.
Perfect. So then what
So-
happens?
2 and x are equal to 1 because they have exponents of 0.
Perfect.
And then I said 1 times, for negative 3, I said 1 times 2 is 2. I got negative 3 to the power of 2.
Mm-hmm. Which is?
Ma'am?
What is negative 3 to the power of 2?
Oh, I said 1 times 1 times negative 3 to the power of 2. And
Okay,
I
no,
said,
that's fine.
and then I said x is to the power of 2.
Okay, perfect. So guys, just remember for this situation over here, and this is sometimes where we make silly mistakes, because that negative was inside the bracket. What this is essentially saying is we're saying negative 3x times negative 3x. Remember, that's what the exponent of 2 is telling me to do. Now, we know that a negative times a negative is a positive. 3 times 3 is 9. X times x is x squared. So whenever you've got a negative sign inside a bracket and it is being squared, you need to remember that your answer becomes positive because you are multiplying a negative and a negative together. So here we have our 1 times positive 9x squared. And now those ones can fall away. They don't actually have an impact, leaving me with 9x squared as my final answer. Right, so a lot of you were just saying 9, but you need to remember that there is still a variable there. And like Nalisa said, what happens to the variable? It's still there. It hasn't disappeared. There's still a variable of x there. So we need to just be careful. Okay, Esther, do you want to help with x?
Yes, ma'am.
Okay.
So any non-zero expression raised to the power of 0 equals 1.
Okay, perfect.
So -3 times 1 is -3.
Perfect. Right, so guys, again, if you understand that that whole bracket, because it's been raised to the power of 0, the whole thing is 1, that's fine. Go for it. You don't need to go and distribute. If you aren't feeling too comfortable, then rather distribute. So if you wanted to distribute, you would have the -3. Let's just write the whole thing out again. So we've got it all here. And we would now distribute the 0 to the exponents inside my bracket. So I would have -3 x to the power 2 times 0, y to the power 2 times 0. And we know that anything multiplied by 0 is 0. So x to the power 0, y to the power 0. Both of those are equal to 1. So -3 times 1 times 1, which gives me -3. So either way, you get the answer of -3. Distributing means maybe 1 or 2 more steps, but you get there in the end. And so again, find what's comfortable for you, find what makes sense for you, and do that. Right, I'm going to wait here in case anyone wants to take a screenshot. Righto. So let's have a look. I feel like I want to find something else first. Let's have a look at A first, and then I'll choose another one in a second. So I want you guys to try question A over here. Remember your laws. So remember your distributive law of exponents. Remember your zero exponent law or your zero exponent definition. And then try and simplify that whole fraction for me. This is now combining all of the laws that we know, and these are the sorts of questions you're going to get, combining the laws that we know into one question. So we need to be able to do all of the laws at the same time, essentially. In this case, there's no negative signs, so you don't need to stress about any negatives here. Anyone got any answers? Esther, I still see your hand up. Is that to answer, or did you just forget to lower it? I'm assuming it's to answer. So Esther, do you want to help me here? Okay. Anyone else want to help me with this question? Do we need another minute? Oh, we're quiet tonight.
And you've got this. You know the laws of exponents. You've got this. Anyone who wants to try?
Okay, another
Amashaji
minute.
gave us an answer before and then never even raised her hand to answer.
Oh, no.
Are you shy, Amashaji?
Don't be shy, guys.
It's like Amashaji gave us the answer in the
Sure.
chat and then the other Amashe answered the the question.
Don't be shy, guys. We all here to
Aw.
support each other.
But I'm glad that you are participating. You learning maths by doing. Keep sharing your answers in the chat. So
Remember, guys, you gotta apply your division laws, your zero exponent laws, your multiplication laws. Like I said, this is a combination of everything. Esther, do you want to try? No. Eddie, do you want to try?
I'll try it, ma'am.
Okay.
So first of all, it's going to be x to the power of 2, y to the power of 4.
Good.
Then it's going to be x to the power of 3, y to the power of 3.
Perfect.
And I'm not sure about this part, but I think it's just going to be like x or just 1.
Just 1, exactly, because x to the power of 0 is 1. Good.
Okay. And then it's going to be x to the power 2, y, and then 1.
And then 1 again. Excellent. Because again, guys, it's to the power of 0, so it's equal to 1. Perfect. Do you want to keep going? Oh,
Yes, sorry, I accidentally muted.
no, don't stress.
So it's going to be x to the power of 5, y
Good.
to the power of 7
Excellent.
times 1. Well, you
Yeah.
already times it, so it's just that. Then it's at the bottom, it's going to be just that.
X squared y.
Yes.
Perfect. Okay, so we multiplied the numerator. So when we say multiply the numerator, we multiplied everything in the numerator. We multiplied everything in the denominator. And now we just need to double check if we can simplify. So for us, do you think we can simplify further? For us, you there? Oh, there we go.
Yes, ma'am.
Okay, so we can simplify further.
Yes, ma'am. For my answer, I said open bracket x y to the power of 2 close bracket to the power of 2. Then I said x open bracket x y close bracket to the power of 3. Then I said times x. Then over open bracket x to the power of 2y close bracket times open bracket xy to the power of 3 close bracket, and my final answer was x to the power of 3 y to the power of 6.
Perfect. Okay, so guys, this is exactly what we need to get to. we still need to simplify our fraction here. So if we take the x's, remember we can subtract the exponent, and it's always the top exponent minus the bottom exponent when we divide. And we would do the same thing with the y's, 7 minus the exponent, 1. And so that therefore means we've got x to the power 3, y to the power 6 as our final answer. So we always want to make sure that we have cancelled out or simplified everything that we can possibly simplify. And so when it's in a fraction, we should never have x's at the top and at the bottom. It should always be either at the top or at the bottom, never both. Because if it's in both, like it is in this step over here, it means we can still simplify further. Alrighty, I'm going to leave that there for you guys to take a screenshot.